Exercise 5E is about purely about the permutations. Okay. Aniyat, have you done this 1A? Can you tell us how many permutations are there for 5 from 7 distinct objects? Yes. Aniyat,
Yes, sir.
then 1A. What is the answer to 1A?
Sir, एक second.
Okay. Uh, yes, Alaiba, can you tell us? Hmm? Uh, how many permutations there are of 5 from 7 distinct objects? Anyone?
Sir,
Sir, it will be 75.
It is 7p5. It is 7p5. If it was to be that you have to choose 5 from 7, then this had to be 7c5. So since it's purely about the permutations, so this has to be 7p5. Okay. Then it says 4 from 9 distinct objects. 4 from 9 distinct objects.
that
Ani, can you now respond to this? 4 from 9. Hmm? Maybe Aliza, Alaiba, क्यों बच्चों?
Sir, 9P4.
Yeah, that is 9p4. 4 from 9. So your 1B's answer is 9p4. Okay. Next is, yeah, okay. Yes, Aliva. It says from 12 books, how many ways are there to select and arrange exactly high half of them in a row on a shelf? Yes. Who would like to respond to this? Mhm. Anup, can you tell us about
Sir,
this second? Anup?
Sir, 12P6 होएगा.
Yeah, 12p6. Acha. Now, this second question is 12p6. Now, if you go in this order, it says how many ways are there to select. If you only had to select, then this was to be 12c6. And then you were arranging. So selecting and arranging. So it is same as 12p6, or you can also write it as 12c6 times 6 factorial. Okay. Next we have, it says, in how many ways can gold, silver, and bronze medals be awarded for first, second, and third places in a race between 20 athletes? So there are 3 different prizes for 3 different positions out of the 20 athletes. So what should be the answer for this third one? Hmm?
20P3, sir.
Yeah,
Sir,
that is 20.
20P3.
Okay, what if the first 3 positions, they had to be given, all of them, they had to be given the gold, gold medals? Then how many, arrangements could be there? Hmm?
20C3.
That would be 20C3, because all of them, regardless of what, like, for example, you are one of those athletes. So you know that even you, if you are at the third place, you will be getting the same gold medal. So this becomes insignificant to be any of the first 3, to be at any of the first 3 positions. Okay. So that is why it would just be 20C3 if the prizes were to be same. Okay. Now in the fourth question, it says from the number of ways in which one can paint his back door and his front door in a different color if he has 14 colors of paint to choose from. So you see now the door,
14.
that will be 14p2. Yes, this is 4A's answer is going to be 14p2. Okay. And look at the B part. It says, in how many ways could Alvaro do this if he also considered painting them the same color? So now, how many colors he has to choose now?
14C1, and because he
Yeah,
only has to choose one.
yeah, exactly.
1, yes.
Exactly. So this is going to be 14C1 or 14P1. Both are same. This is 14C1 or 14P1. Now, there are some interesting questions coming ahead now. Question number 5. It says, find how many of the arrangements of 4 letters from A, B, C, D, E, and F begin with the letter A. Now, the arrangements, the first thing you must note down, that is the arrangements of 4 letters, okay? And these are 6 letters over here. And they all these arrangements should begin with the letter A. So if I make a diagram for this, this is, so we have A fixed over here, okay? So how many arrangements of these letters can now be? Hmm? This is a very
Sir,
interesting.
5P3.
Into 5
5,
factorial.
5,
P3.
5P3.
5P3.
exactly. Because you have to choose uh, and arrange 3 from the remaining 5. So this is going to be 5P3. This is going to be 5P3. Oh, now look at this B part. This is very interesting. It says contain the letter A. Now this letter A has to be there, but this is not the condition that this has to, this arrangement has to begin with the letter A. This A can be anywhere. So that means these 4 letters must contain the letter A. And you have to tell the number of arrangements. Yes. What do you think?
64.
Sir, it'll be 5P3 times 4.
5
Sir,
P.
6.
It's just 1 minute. Now, one of you are saying 5P3.
Oh, sorry, sir. It says contain the letter. I get it. Sorry.
Okay. By the way, this was the correct answer, 5P3 times 4. And I was going to ask you that why it is correct. Hmm?
Sir, because A can be anywhere. तो आपके पास 4 positions हैं which are open.
Exactly. You can fix your A at the first position. You can fix A at here. You can fix it here. You can fix it here. So there are 4 possibilities for this A. So that is why this 5P3 times 4 was the correct answer. Okay. Acha.
Sir, we can also do 5C3 into 4 factorial, right?
Exactly. That is what I was about to do it the way you have done it. It had to be 5C3 because you have already 1 letter in your hand, okay? And you need to have 3 more. You have already 1 letter. So let me write this as, like, suppose you have to have this A, okay? And then you have 5 more. From these 5 you need 3 more. So now when you have chosen 3 more, so now altogether you have 4 letters in your hand, and now you're going to arrange them. So that is how you can do this. This is 5C3 times 4 factorial. Please make it clear if it is if there is any confusion with you. So both of these answers are correct. 5C3 times 4 factorial or 5P3 times just 4. Okay, few people are like sitting quietly, so that means I can move on to the 6th question then. It says from a group of 10 boys and 7 girls, 2 are to be chosen to act as the hero and the villain in the school play. Find in how many ways this can be done if these 2 roles are to be played by any of the children. Yes.
17P2.
Sir, it'll be 17P2.
Yeah, this is 17P2. Okay. There are 7 children. We have 2 roles for them. So this is 17P2. B part. 2 girls or 2 boys? Yes.
10C2 plus 7C2 into 2 factorial.
10P2.
Uh, I think you should directly write it as 10P2 plus 7P2. That is how you should go. Or if you want to use the C, then this would be 10C2 plus 7C2 times 2 factorial. You will have to keep all of them in the brackets. Okay. Or like if you want to use this, you can also write it like this: 10C2 times 2 factorial, 7P2 times 2 factorial. So any one of them would work for you. If you have any objection, let us know. If there is no objection, then you move on to a boy and a girl. Okay. A boy and a girl.
1 into to
There will be
7C1.
7. There
Yes.
will be 10p1 times 7p1 plus 2 factorial or
Yeah, yeah,
So
yeah.
into 2.
So this is 10C1 times 7C1 times 2 factorial, because any one of them can be hero or the villain. So first of all, you have to choose a boy and a girl, and then you can give them the rule. So this is 10C1 times 7C1. Okay? If there is any problem, you please let me know. Otherwise, I'm going to clear all this working here. Okay, you haven't said anything about your problem, so I'm going to move on. Okay. Yes, we can go up to this question number 9. Okay, look at this 7th question now. I'm giving you 5 minutes. You please go through these questions, and we can try. We can discuss them together. The 7th question is, from a set of 10 rings, a jeweler wishes to display 7 of them in their shop window. The formation of the display is shown in the diagram opposite. Find the number of possible displays if from the set of 10, the ring with the largest diamond must go at the top of the display. So the ring with the largest diamond. So this is the ring, suppose, which is here. Now we have fixed it here. There is no problem, nothing to think about. Okay, how many arrangements can, this is one ring with the largest diamond, so we have kept this at the top. So now we have to think about how to arrange the remaining 6, whatever we have here. Okay, so the remaining 6 rings have to be arranged. So what would be the answer to the part A?
9P6.
9p6.
This is 9p6. Okay, so there were 10 rings, one has been fixed here, so remaining 6, so that is going to be 9p6. Now it says the most expensive ring must go at the top. So this is again the most expensive ring over here, with the 2 least expensive. So these are 2 least expensive over here, and then it says that's it. So again, nothing to be bothered about this one at the top. This is the most expensive. This is obviously one. Okay. Now these are the 2 least expensive. So I should have 2 factorial for these 2 because they can be in any order. Times, we have used 3 from the 10. How many are left? Hmm?
7.
7.
4,
7.
like 4 to be from 7. Yes, so 7 we have left, and we have to put 4 over here. So this is going to be 7p4. So can you relate to this? And if you
So
can,
won't it be 64? Because we also have a diamond one fixed over there. So 10 minus 3.
Nini, beta,
Okay, okay.
this is a different situation, beta. This one is a different situation. Part A and part B, they are 2 different. Now we are keeping at the top the, not the diamond one, the most expensive one. Okay. Okay, so question number 8. Using each digit not more than once, how many even 4 digit? Now there are 2 conditions. One is that we should have even. The second is that it should be a 4-digit number from these digits, which are 7 over here. Okay, so we should quickly have this diagram over here and see where do we have a condition here. So we have a condition here. We can only have an even digit over here, which are going to be 2, 4, and 6. Any of these 3 can be fixed here. Do we have any condition at the beginning of this number? At this
No, sir.
no. Okay. So it means I'll first of all say, okay, I can have any one of them at the end times. Now there are 3 slots, and how many digits are available?
6.
6.
6.
Yeah, this is going to be 6p3 times 3p1. Okay. So from here, I'm going to end this session of this permutations. Our next, uh, I mean, part would be from this exercise, which is going to be exercise 5F. Okay, so let's end this session here, and you people come back for the combinations exercise. Okay, thank you very much.